Hi everybody, welcome back. Today we're going to continue more with solving systems of quadratic and linear equations. Instead of graphing now, we're going to move on to solving by substitution. So the way that we're going to go ahead and do this is very similar to how we solved systems of equations when we were doing linear equations. So for example, if you look at the example problems here, we're saying that y is equal to both of these equations. You can take what y is in the top equation and put it in for y in the second equation. So you would end up with 3x plus 5 is equal to 6x minus 7. And once we have them set equal to each other, we can use what we know how to do with solving equations to solve this. So the first step would be to get all of your x's on one side. So I'm going to do that by minusing 6x to both sides. I end up with a negative 3x plus 5 is equal to a negative 7. Now I need to minus 5 to both sides. I end up with a negative 3x is equal to a negative 12. Divide both sides by negative 3, and I learned that x is equal to a positive 4. Now remember with systems of equations, once you find what x is, you have to go back and figure out what y is. And the nice thing about it is it doesn't matter which equation you use. You can use the one that seems the easiest to you. For me, the y is equal to 3x plus 5 seems easier. So instead of saying y equals 3x plus 5, I'm going to say 3 times 4 because that's what I just decided x was when I solved it, plus 5. So y is equal to, well, 3 times 4 is 12. Plus 5 is 17. So if I were to graph these lines, they would intersect at the point 4, comma, 17. So I'm going to take those same skill set, that same idea, but instead of having two lines, I'm going to do it with quadratic and linear equations. So looking here, steps to solve. The first thing that we're going to do is set the equations equal to each other, just like we did in the example above. After that, you need to add or subtract the linear term. And in case you're not sure which one that is, that's the one with the x. And the constant term. And that's the one without the x. Our whole goal here is to get the equation equal to 0. Once the equation's equal to 0, we're going to factor to get all x values. Remember that you're going to have to set each parenthesis equal to, cross that off, to 0 to find those numbers. The last step that we do is you substitute both x values into either equation to find y. Now I'm going to tell you a little hint. When we say either equation, really what we mean is the linear equation, because that one is super duper easy to do. But of course, to double check your work, you'd want to substitute it into both equations. Okay, so let's see how this looks like when we get started on these problems. Looking at example A here, we have y is equal to x squared minus 4x plus 2, and we also tell you that y is equal to negative 2x plus 2. So you're going to take what y is and put it in y's place. So instead of saying y equals, we're going to say, oops, sorry about that. We're going to say x squared minus 4x plus 2 is equal to negative 2x plus 2. So my first step is going to be to add my linear term. So plus 2x plus 2x. Notice I'm lining up my x's so that way all my like terms are together. Then I need to subtract my constant. And again, I'm lining up all of my like terms together. So when I do that, I have nothing left on the right-hand side of the equation. And now I just go piece by piece. 2 plus a negative 2 gives me 0, so they also cancel out. Negative 4x's plus 2x's give me a negative 2x. And then I'm going to bring down my x squared. So now that I have this equation equal to 0, we are actually going to look for a GCF between both terms to factor this. So what do x squared and negative 2x have in common? You guessed it, they both have an x. So I'm going to take that x and write it out front and write down what's left inside. X squared divided by x is just x. Negative 2x divided by x is negative 2. And we set that equal to 0. So in order to get our two solutions, we need to set each individual factor equal to 0. So x equals 0 and x minus 2 equals 0. Well, this one's solved for me. Over here, I'm going to add 2 to both sides, so I get x equals 2. So my two possible answers for x are 0 and 2. So I need to pick an equation to enter them into to see what my y values would be. I'm going to choose the bottom equation, that's my linear equation, because that's the easier one to deal with. So for x equals 0, I have negative 2 times 0 plus 2. Now you can enter that exactly as it appears in your calculator, or we can use a little bit of mental math. What's negative 2 times 0? Right, it's 0 plus 2, so y is equal to 2. Good. So my first place where these two, where the parabola and the line would intersect is at the point 0, 2. Now I'm going to go through and do that same process, but for x equals 2. So again, I have negative 2 times, in this case, it's 2 plus 2. So you can enter that directly as it appears into your calculator or use a little bit of mental math. Negative 2 times 2 is negative 4 plus 2. So y is equal to negative 2. So the other place that this parabola and line would cross at is at 2, negative 2. So these are both of my solutions. Let's go ahead and look at another problem. So looking at letter B, we're going to set both equations equal to each other. So we're going to take this value for y and put it in for y here. So I have negative 3x squared minus 5x plus 2 is equal to x plus 2. Now I'm going to subtract, because it's positive, so I'm going to subtract my 1x from both sides. Again, notice how I'm lining up my x's together. And then I'm going to subtract my 2 from both sides. When I do that, all of this cancels out. So I'm left with 0 on the right-hand side. Coincidentally, my 2's cancel out also on my right-hand side. And now I'm going to go ahead and combine everything else. Negative 5 minus 1 is a negative 6x. And then I'm going to carry down my negative 3x squared. Now that I have it all together, I'm going to factor out my GCF. So if I look at both terms here, remember, if the first one's negative, you need to take out a negative. And then what do 3x squared and 6x have in common? Well, they both have a negative 3x. So that negative 3x comes out front. Oops, sorry. And what's left inside the parentheses now? Well, negative 3 over negative 3 leaves me just with 1x. And then negative 6 divided by negative 3 is a positive 2. And that's equal to 0. Now that I have my two equations, I can find out what y is. So I set them each equal to 0 and solve. So x plus 2 equals 0. So in my first equation on the left-hand side, to get the x by itself, I need to divide both sides by negative 3. When I do that, I get x is equal to 0. On the right-hand side, to get x by itself, I need to subtract 2. When I do that, I get x is equal to negative 2. Now that I have my x values, I need to pick an equation, and it doesn't matter which one, to substitute it back into. And like I said before, your linear equation is easier. So my linear equation is y equals x plus 2. So instead of saying x, I'm going to say 0 plus 2. So y is equal to 2. The first place that they would intersect is at the point 0, 2. Now I'm going to do the same thing for my other solution. Instead of saying x plus 2, I'm going to say negative 2 plus 2. And if you add those up, you get 0. So my point is negative 2, 0. If I were to graph both of these equations, they would intersect at the points 0, 2, and negative 2, 0. Okay, let's try one more equation. So for letter C, again, we're going to set each equation equal to each other. So we're going to take what y is and put it in y's place. So I have a negative x squared plus 8x minus 3 equals 5x minus 3. And again, remember, we're doing a case of the opposites. Because my 5x is positive, I'm going to minus 5x to both sides. And because my negative 3 is negative, I'm going to add 3 to both sides. And when I do that, these cancel, and actually, these cancel again. So now I'm going to combine my like terms. 8x's plus negative 5x's leaves me with 3x. And then I'm going to carry down my negative x squared. So when I'm looking at that equation, how do I factor it? Well, remember, because the number in front is negative, I'm going to be taking out a negative. And if you want to put like a 1 there to make it easier, you definitely can. And then what else do they both have? Right, they both have an x. So when I factor this out, I get negative 1x times, okay, well, there's my negative 1. X squared over x is just x. 3 divided by a negative 1 is a negative 3, is equal to 0. So now to find my two solutions, I take each factor and set it equal to 0. So negative 1x equals 0, and x minus 3 is equal to 0. So in the equation on the left, how do I unattach that negative 1? You guessed it, divide both sides by negative 1. When you do that, you find out that x is equal to 0. On the right-hand side, what do I do? Yes, awesome. We're going to add 3 to both sides. So x is equal to 3. Now that I have my x values, I can choose either equation. Again, remember the linear one's easier. That's 5x minus 3. So I'm going to take 0 and put it in place of x. So 5 times 0 minus 3. So that means y is equal to, well, what's 0 minus 3? Good, negative 3. So my first point at which they would intersect is at 0, negative 3. I'm going to do those same steps, but now I'm going to substitute 3 in for x. So 5 times 3 minus 3. Okay, 5 times 3 is 15. 15 minus 3 is 12. Good. So then the second point that this graph and linear equation would intersect is at the point 3, 12. I think that's all I have for you today. If you have any questions at all, please feel free to reach out to your teacher. Otherwise, I truly feel that you have the skills necessary in order to be successful on today's classwork. Thanks, and I hope you have a fantastic, great day. Bye.